Okay, inverses of functions. If you have multiply by 2, in other words, if you have this and you want to solve it for x, is that possible? Sure. You multiply it by 1/2 to solve for x. So the opposite of multiplying by 2 is either multiplying by 1/2 or dividing by 2. If you want to do this, that's fine as well. Is that a function? Yes, it is. You can check it with the vertical line test if you want to. If you're squaring something and you want to solve it for x, what do? You take its square root. Or a better way to put that actually would be x to the 1/2. This one's trouble because this is not a function. Root x is, but x to the 1/2, which is what we should technically be using, the one where you can get positive or negative answers, that is not a function because it gives you two values. I'll give you an example. If I take 4, I ruined the surprise. Let me try that again. I take a number, I square it, and the result is 16. And then I take that number to you and say, okay, what did I square to get 16? And you say 4. And I say, no, it was -4. I could be right. There's no way to be sure which number I squared in the first place. And that means that this function is not what they call one-to-one. It means there's no definite way to undo something after it's been squared and get the original number back. Therefore, that inverse is not a function. Once you squared something, the result is going to be positive, but you don't know, there's no way to tell anymore if the original value is positive or negative. Something gets lost when you square a number. And so there's no way to invert it and be positive that you got the original back. So no to the inverse there. Not a huge deal, but it comes up occasionally. If you're taking a reciprocal, 1/x, is there an inverse for that? Yeah, there is, and the funny thing is, you do the reciprocal again. If I have a number like 2/5, I flip it over, it becomes, say, 5/2. If you want to get the original back, just take this and flip it again, and look at that, you've got the original. So the reciprocal function, 1/x, is its own inverse. That isn't always true. Some functions like x squared have totally different inverses, like the radical function. But the reciprocal is its own inverse. It's a mirror image of itself. And is it a function? Yep. It's undefined at 0, but that's all right. It's 1-to-1. That's what we care about. And if you're dividing by 3 and then adding 1, so if you have, say, x/3 plus 1, how do we get that back? Think about example 1 where we were talking about socks and boots. Here we took x, divided it by 3, and the last thing that happened was adding on the 1. That means if we're undoing these steps, that -1 is the first thing that's got to come off. That's like the boots. This is like feet. Dividing by 3 is the socks part, plus 1 is the boots part. We have to get the boots off first, and then take the result and triple it to cancel out this 3. We have to do all those things in the opposite order and work our way back in towards the x. And 3 times x minus 1 is a perfectly nice function. It's 1-to-1. No troubles with that.